Welcome you all. In this section, we are going to discuss about the detection of multicollinearity. How we can detect the multicollinearity. So far, we have examined what is the nature of multicollinearity, what are the causes and consequences of multicollinearity. Now we want to discuss how to detect a multicollinearity. First detection method is that the estimated result will have high R square but few significant T ratios. Second one, by examining the pairwise correlation among the regressors. Third one, examination of partial correlation coefficients. The fourth one is by examining the auxiliary regressions. Fifth one is Eugen values and the conditional index, and fourth one by examining the tolerance and various inflating factor. These are the method usually used for detecting the multicollinearity. That is, if the estimated results have high R square value and the estimated sum of the parameters are insignificant, then there is multicollinearity. We can examine the pairwise correlation among the regressors, and if the pairwise correlation is very high, then there is multicollinearity. Similarly, we can compute the partial correlation, and if it is high, there is multicollinearity. And auxiliary regressions can also be calculated, and from that we can we can detect the multicollinearity. Eugen value and conditional index can also be used for detecting and the multicollinearity. And finally, the tolerance and various inflating factor that we have already seen is also used for detecting the multicollinearity. The first one is high R square but few significant ratios. We have also already seen that if the multicollinearity exists, then in that case the T ratios will be insignificant, whereas the R square value will be very high. If this situation prevails, then we can say that there is the problem of multicollinearity. If the R square is say 0.8 and F test in most cases will reject the hypothesis that the partial slope coefficients are simultaneously equal to 0, but the individual T test will show that none or very few partial slope coefficients are statistically different from 0. Then second one is pairwise correlation among the regressors. If the pairwise or zero order correlation coefficient between two regressors is high, then in excess of 0.8, then there is multicollinearity. There is a high zero order correlations are sufficient but not necessary condition for the existence of multicollinearity, because it can exist even though zero order simple correlations are comparatively low. Then third one is the examination of partial correlation. Farrar and Glober have suggested that the partial correlation coefficient test, that is regression of y on x2, x3 and x4, and find out R square 1.234 if it is very high, but R square 2.34 and R square 3.24, R square 4.23 are comparatively low, may suggest that the variables x2, x3 and x4 are highly intercorrelated, and that at least one of these variables is superfluous or it is collinear. That is high R square, few significant T ratio, pairwise correlation will be high, then partial correlation, that is the regression of y on x2, y on x3 and y on x4, then compute the R square of the multiply as well as the partial correlation coefficient. Then we will, if these partial correlation coefficients are comparatively low, which suggests that they are collinear. Then next one is auxiliary regression. Auxiliary regression is that regress each xi on the remaining x variables and compute the corresponding R square, which we designated as Ri square. Each one of these regression is called, that is, regress each xi on the remaining x variables and compute the R square. If they compute, then compute the f value using this formula. Then if the computed f exceeds the critical f value at the chosen level of significance, it is taken to mean that the particular xi is collinear with the x. If it does not exceed the critical fi, then it is not. If it it computed exceeds the Fi, then there is collinearity. If it does not exceed the critical Fi, then it is not collinear. This is the auxiliary. Auxiliary means regress x1 on x2, then take the x1 on the remaining x variable and x1 x the regress x1 on the remaining x2 and x3 and compute the R square value. Then compare it with the F table. Then next one is the eigenvalue and the conditional index. Eigenvalue is defined as k equal to maximum eigenvalue divided by the minimum eigenvalue, and conditional expense is the root of this one, that is root of k. If k is between 100 and 1000, moderate to strong multicollinearity. If it exceeds 1000, it is severe multicollinearity. If conditional index is between 10 to 30, there is moderate to strong multicollinearity. If it exceeds 30, there is severe. If conditional index is between 10 to 30, there is moderate to strong multicollinearity. If it exceeds 30, there is severe multicollinearity. And that is if the eigenvalue 100 to 1000, then strong. If it exceeds strong, if it exceeds 1000, severe. If in the case of the conditional index, if it ranges from 10 to 30, there is moderate to strong. If it exceeds 30, then there is severe multicollinearity. And the next important detection method is the tolerance and variance inflating factor. Variance inflating factor that we have already seen. The variance inflating factor is defined as 1 by 1 minus R23. This R23 is the correlation coefficient. If R23 tend towards 1, then we can say there is high collinearity. And the tolerance is the inverse of variance inflating factor. That is, if tolerance is 0, the variance inflating factor will be 1, and there will be high degree of collinearity. If it is closer to 1, the greater the evidence of that Xi is not collinear. If tolerance is 1, it is not collinear. If tolerance is 0, there is collinearity. Therefore, these are the important detection method. If the regression result have high R square but few significant T ratio, the pairwise correlation coefficient, the partial correlation, compute the partial correlation if it is and check the criterion, then auxiliary regression, eigenvalues and conditional index, tolerance and variance inflation factor. These are the methods used for the detection of the multicollinearity. All these factors or these methods can be used for detecting the multicollinearity.